Hello, Advanced Algebra students. I hope you are having a fantastic day. I am so happy to be working with you. I love math and I love helping you. I hope that you're doing well and that this class is going well for you so far. We are going to do lesson 1.7 right now. And I would say of all the, and as you know, this is in the Algebra 1, Chapter 1 book, but of all the algebra concepts that we are reviewing with you, this is probably the one that is the most likely to be something you have not seen before. So I would say pretty much everything we've been doing in class up until this date should be review of material that you've done many times before. However, although this topic is technically an Algebra 1 concept, many Algebra 1 classes do not include this. So if this looks new to you, it may be because you haven't seen it before. So the section is 1.7. and the topic is solving absolute value equations and inequalities. Now, this is a lesson I really wish I could do with you in person because it is kind of fun to make it a little bit more interactive, but I will do my best to explain this clearly to you, and then I will look forward to helping you during Zoom. And again, don't forget that you can zoom in on the board or pause as you need to. So in order to do this lesson, however, it is essential that you understand what absolute value means. Does anybody know what does it mean when I say, for example, what is the absolute value of -5? So we'll just do this as example 1, very straightforward. Absolute value of -5. And by the way, these vertical lines here are the absolute value symbols. So absolute value means distance from 0. How far is that spot from 0? So if you look at -5 on a number line, it is 5 spots away from 0. So that is why the absolute value of -5 is +5. Now some people incorrectly think, oh, absolute value just means change the sign. That is not accurate, because if I asked you, let's do this for example number 2, if I asked you what is the absolute value of +5, I'm still asking you how far is that number from 0. So +5 is also 5 spots from 0. So absolute value means distance, so it is always going to be positive. All right, now let's solve a little bit more complicated equation. Let's do example number 3. On example number 3, I have the absolute value of 7x minus 2 equals 5. So the absolute value of 7x minus 2 equals 5. Now, please, please, please do not try to do opposite operations and isolate x, because you cannot do that until you've gotten rid of the absolute value signs. So that our basic strategy for handling all of these equations and inequalities is going to be first, rewrite your problem as 2 separate problems, then solve. So what we need to do is we need to rewrite our original problem, taking into account what absolute value actually means. So if our first problem is that the absolute value of 7x minus 2 is 5, I know that in order for that statement to be true, it either has to be the case that 7x minus 2 equals +5, or that 7x minus 2 equals -5. So I take my original problem, I rewrite it as 2 separate problems. Now I can solve it the way I've always solved equations, using opposite operations. So I would be adding 2 to both sides of the equation. And on the first one, I get that x is 1. On the second one, I get that x is -3/7. So we're getting 2 different answers, and that will almost always happen, that we get 2 separate answers to any absolute value problem. We can check to see why this is correct by plugging x back in. So if I plug 1 in for x in my original equation up here, I would be taking the absolute value of 7 times 1, which is 7, minus 2, which equals 5, and the absolute value of 5 is 5. That does work, so I can put a check mark there. If I plug in -3/7 here in my original equation, and I take 7 times -3/7, I would end up with -3. -3 minus 2 would be -5, And again, the absolute value of negative 5 is positive 5. So you do need to check your work. Now, sometimes what will happen when you plug your answers back in is you will get an answer that does not work, and that is what's called an extraneous solution. So that may come up in your homework. Let's go ahead and do one other example of this basic type of absolute value problem. This is more complicated. 4 times the absolute value of 2x minus 7, and then close that absolute value bracket, and then go plus 5 equals 9. So the 5 is outside the bracket. Now, we cannot divide this problem into 2 separate problems yet because we haven't isolated the absolute value. We must do that first. So the opposite of adding 5 would be subtracting 5. So now I have 4 times the absolute value of 2x minus 7 equals 4. The opposite of multiplying by 4 is dividing by 4, so I'm going to divide both sides by 4 and get the absolute value of 2x minus 7 equals 1. Now that I've isolated the absolute value, I can break this up into 2 separate equations. 2x minus 7 equals positive 1, and what would my other equation be? If I need the absolute value of 2x minus 7 to be 1, what are the 2 ways I could be 1 spot away from 0? Either I could be at positive 1, or what else could be true? I could be at negative 1, right? So my other possibility is 2x minus 7 equals negative 1. I need to write both of those down and solve. When I add 7 to both sides, I'm going to get 2x equals 8, or x equals 4 from my first equation. And here, I'm going to get 2x equals 6, or x equals 3. And in that particular case, both answers do work if I plugged them back into the original problem. So what we've just done there is we have solved that absolute value equation. This one right here and this one right here. These are absolute value equations. Now we also are going to be working with word problems and inequalities. So typically, I don't like to do too many word problems on a video notes just because I know that they're so long and tedious to watch as they are. But because this is a kind of difficult problem, and I think there is one like this in your homework, I do want to do it with you. So the next example, I believe this would be example 4, is to write and solve an absolute value equation for the number of hours a boat will travel if it is going 25 miles per hour and needs to reach 80 miles plus or minus 10 miles. So again, don't feel like you need to write that down, but you can write down example 4, and then D equals R times T, because that is our basic equation we always use with distance, rate, and time. And then it says we need to find the number of hours a boat will travel. So again, we always look at the sentence to see what our variable is. So X is going to be the number of hours a boat will travel. Now in this particular case, it's going 25 miles an hour, and it needs to reach 80 miles plus or minus 10. So because, and this is the key here, in the absolute value problem it says plus or minus 10. That is our clue that we are going to want the absolute value of something to equal 10, because we want our answer to be positive or negative 10. And so when we do an absolute value set equal to 10, that will give us that scenario. Now, if the boat is going 25 miles an hour for X hours, the distance that will travel will be 25 times X. And then when it says 80 miles plus or minus 10, we would subtract off that 80. Now this is kind of confusing, but I think actually it makes more sense to solve it and then kind of look back at what we did here. If we break this into 2 separate equations, we get 25x minus 80 could be positive 10, right? Because they wanted it to be plus or minus 10. And then our other equation would be 25x minus 80 equals negative 10. So this original problem here does result in the two equations we're looking for. When we add 80 to both sides, we're going to get 25x equals 90, or x equals 3.6. Here, when we add 80 to both sides, we're going to get 25x equals 70, or x equals 2.8. So the boat would need to travel at least 2.8 hours and at most 3.6 hours. Okay, so that's an extremely challenging problem. I did try to make it very similar to the one that appears on your homework. Now, let's go ahead and do, I'd say, 3 more examples. Example number 5 is going to include an absolute value inequality. So we've been doing absolute value equalities. Now we need to look at absolute value inequalities. All right. So let's just do a really straightforward one. Let's do the absolute value of x minus 8 is less than or equal to 5. Now, how is this problem different from the last 4 that I did? What's different about this problem? The absolute value of x minus 8 is less than or equal to 5. The difference is it doesn't say equal to. It says less than or equal to. So this is an inequality, not an equality. So it means something entirely different. Now, instead of saying that we're 5 spots from 0, we're saying that we're 5 spots or less from 0. So we could be 1 spot from 0, 2 spots from 0, 3.5 spots from 0, all the way up to 5 spots from 0. So think to yourself visually in terms of the number line, where would I need to be on the number line to be 5 or less spots from 0? An obvious first answer is, well, I could be between 0 and 5. That would absolutely work. But there's a whole other range that you can look at there. What's another way that you could be 5 or less spots from 0? Hopefully you're thinking of the negatives, because you could be at -5, -4, -3, -2, -1, and you would still be 5 or less spots from 0. So in this particular case, we are going to break up our inequality into 2 pieces, just like we did with the inequality, but we're going to have to use inequality symbols this time. So one possibility for this problem is that x minus 8 is less than or equal to +5. Now this is the hard part. The other possibility is that x minus 8 is what? What symbol would I need to be compared to -5? Would I want to be less than or equal to -5 or more than or equal to -5 if I want to be closer to 0? The answer should be greater than or equal to -5, because remember, and I wish I could show you my number line, but I don't think it would show up really well on this video. I'm not sure that it would reach there. If I'm at -5 and go to the right, then I will be closer to 0. So we need x minus 8 to be greater than or equal to -5 because we want to be moving to the right towards 0. All right, now we solve both of these inequalities just like we did in our lesson on inequalities. And one answer is that x is less than or equal to 13. When we add 8 to this equation, we get x is greater than or equal to 3. So we graph these kinds of solutions. We put 3 on the number line and 13 on the number line. We're going to use closed circles, and we're going to be bigger than 3, but less than or equal to 13, bigger than or equal to 3, less than or equal to 13. This will be the solution for this inequality. So inequalities, in my opinion, are a lot harder, and I would say of everything we've done in chapter 1, this is the hardest problem so far. So if you're feeling like this is kind of confusing, you're not alone. We are going to go over several more like these during class. Okay, now let's look at an inequality with a greater than symbol. So the first one was a less than or equal to. Let's look at one with a greater than symbol. So let's do example number 6. Let's take the absolute value of negative 4x plus 14 is greater than 18, okay? Now, I still want to break this up into 2 pieces, but in this case, we have to think to ourselves, if we want to be more than 18 spots from 0, what are the 2 ways on the number line I can be more than 18 spots away from 0? The obvious first one is I could be at more than 18 to the right, right? So I could be 19 spots away, 20 spots away in the positive direction. But you can't forget that the negatives also have to work. So I could be at negative 20, negative 25, and negative 30, and so on. So see if you can take a minute and write down what you think the 2 inequalities would be for this example. Example number 6. So the first one would be that negative 4x plus 14 is greater than 18. The other one would be that negative 4x plus 14 is less than negative 18, because we would be going to the left to be further away from 0 at that point. Okay, when we subtract 14 from both sides, we get on the first equation, now we're going to get here negative 4x is greater than 4. When I divide by a negative number, don't forget I have to switch the symbol. So here it becomes x is less than negative 1. On this one, I'm going to subtract 14 from both sides and get negative 4x is less than negative 32. And when I divide by negative 4, I get x is greater than 8. So in both of these, we had to flip the symbol around. Now, when I draw this on a number line, I'm going to put a number negative 1 on my number line and an 8, and put open circles above both. The arrows are going to be pointing away from each other in this case, because I need to be more than 8 spots to the right, or more at negative 1 or to the left, beyond negative 1, I should say, not including negative 1, but beyond negative 1 to the left. Okay, last example, and you guys have done a fantastic job. If you're still watching this video, I am so proud of you. Example number 7 is a word problem. Now, I'm sure I have told you this by now, but you hopefully know that I'm a very avid motorcyclist. I live for riding my bike, totally love it. And so I do kind of take the opportunity every now and then when I put word problems in here to talk about my bike. So, example number 7 says, Kathleen is pumping premium gas into her motorcycle. The cost per gallon for premium is $3.75. Write and solve an absolute value equation to represent how many gallons of gas will be pumped if the total is $10 plus or minus 25 cents and anywhere in between. In other words, the answer should represent a range of gallons pumped. Now, we could probably solve this without using an absolute value inequality, but because this is the section we're on, that's how we're going to do it. Now, it says that it wants us to solve for how many gallons will be pumped. So I'm going to make x be the total number of gallons. Total number of gallons. Now, just like with our last problem that we did, I do think it's easier to set up the absolute value inequality and then see why it works. If the cost per gallon is $3.75 and I pump X gallons, my total cost is going to be 3.75X, right? But now it says we want to figure out how we can represent this if the total is 10 plus or minus 25 cents. So we're going to subtract the 10 to take into account that part we've already taken care of. And then we're going to say is less than or equal to 0.25 because we want our total to be less than or equal to 25 cents. When we break this up into 2 separate inequalities, we'll see how this does indeed work. So if we want to be less than or equal to 25.25, 0.25 or 25 cents from zero. One possibility, obviously, is that when we take my total and subtract 10, I'm gonna get less than or equal to 25 cents. But the other possibility, if I'm thinking of the left side of the number line, is that 3.75x minus 10 is greater than or equal to negative 0.25. Now when I add 10 to both sides, I get 3.75x is less than or equal to 10.25 here. And then when I divide both sides by 3.75, I get x is less than or equal to 2.73. So that's one part of my answer. If I pump 2.73 gallons or less. Now, since I want my total to be only 25 cents away from $10, I also have a minimum amount of gallons that I have to pump, and we're gonna figure that out here. If I add 10 to both sides, I get 3.75x is greater than or equal to 9.75. I divide both sides by 3.75, and I get x is greater than or equal to 2.6. So this is very similar to the boat example. I think it was a boat example, yep, on the front of my notes here. So I need to pump between 2.6 gallons and 2.73 gallons for my total cost to end up being $10 plus or minus 25 cents. Okay, you guys have done an amazing job doing these notes, and I can't wait to see you in Zoom. Bye.